Okay, so we're doing 6.3a, trig functions and their properties. So let's first look back again at the 6 trig functions in the unit circle. So remember sine is, I'm talking about sine here, is opposite over hypotenuse, and opposite is y, right, of that angle. So y over 1. Y over 1 is just y, right? So in the unit circle, sine is y, cosine is x over 1, which is x, right? And tangent is opposite over adjacent, which is sine over cosine. Remember, tangent is sine over cosine, which is y over x. Okay, so these are the things that we really need to just remember them, right? And then cosecant, remember cosecant is the reciprocal of sine, 1 over sine, so it's 1 over y, okay? Secant is 1 over x, because it's 1 over cosine. And then cotangent is just the reciprocal of tangent, which is x over y. So these are the relationships that need to come readily to you every time you think about these things. You should know them. Okay. So here we're talking about the sign of the trig functions on the quadrant. Remember last time we did this and we kind of thought about it. We thought, oh, where would x be positive? Where would y be negative? Things like that. So if I give you sine, you should know, oh, where is it positive? Where is it negative? Right? But there is an easier way to kind of just memorize where they are. So the easy way to remember which trig function is positive or negative on which quadrant is we remember it by saying all students take calculus, right? All students take calculus. So it goes from the first quadrant and to second to third to fourth like that. So all is in the first quadrant. So all functions are positive in this quadrant, okay? All 6 functions are positive here. S is for sine. So sine is positive in this quadrant. And sine is the same as cosecant, right? Because they're like twins. Because cosecant is just the reciprocal of sine. Right? Sine and cosecant are positive here. And then tic is for tan. Tangent, right? Tangent and cotangent are partners because they're reciprocal of each other. They're both positive in this quadrant. And then calculus is for cosine. And cosine and its partner secant are positive in this quadrant. So again, all students take calculus, A, S, T, C, right? All functions are positive here. In the second quadrant, sine and cosecant are positive. The other ones are negative, right? All 4 are negative. The other 4 are negative here. So here, these 2 are positive and the other 4 are negative. And here, these 2 are positive and the other 4 are negative. So each function has 2 quadrants where it's positive and 2 where it's negative. For sine, it'll be like first and second. They're positive here, but negative down here. For tangent is 1 and 3, right? 1 and 3, they're positive, but they're negative over here. Cosecant will be 1 and 4, but they're negative over here. So let's use that and do some practice here, right? Here, which quadrant is this where sine is positive, but cosine is negative? Sine is positive, so 1, everything is positive, and 2, sine is positive with 1 and 2 here, right? But cosine is negative where? Cosine is positive in 1 and 4, so it's negative in 2 and 3. So the one that they share, sine is positive, but cosine is negative, is in the second quadrant. So quadrant 2. And here you have cosine is positive, so that's 1 and 4. Cosine positive 1 and 4. Tangent is positive in 1 and 3. So the one that both of them are positive is in quadrant 1. Now tangent is positive and cosine is negative. Tangent is positive in 1 and 3, right? 1 and 3, all and tan. But cosine is negative. So cosine is negative in 2 and 3. So then what they share is quadrant 3. Cosecant is positive. Cosecant is positive in 2 and 1, just like sine, right? 2 and 1. And then cosine is negative, which is in 2 and 3. So the one that both is quadrant 3, 2. Secant is positive. Secant is same as cosine, so positive in first and fourth. Cotangent is negative, so cotangent is positive in here and here, 1 and 3, so it's negative in 2 and 4. So the one that is both true is quadrant 4. Last one, cotangent is positive, tangent is positive. Because both of these are the same, okay, tangent and cotangent share the quadrants because they're just reciprocal of each other. So they're both positive in 1 and 3. So the possibilities are 1 or oh, that should be 3. Sorry. Quadrant 3 or 1, not 4. All right, so here's something called the Pythagorean identities. And so it starts from the Pythagorean theorem, x squared plus y squared is equal to 1 because a squared plus b squared is equal to c squared. So in this case, we have x squared plus y squared is equal to 1 squared, which is 1. And remember that cosine is x, right? Cosine is adjacent. Sine is y because sine is opposite. So x squared is cosine squared and y squared is sine squared. Right? X squared is cosine squared because x is cosine. So the Pythagorean identity is saying cosine squared plus sine squared is equal to 1 on the unit circle. Right? And then you can manipulate this by dividing everything by sine or divided by cosine, and you get two other equivalent statements. So tangent squared plus 1 is equal to secant squared. Cotangent squared plus 1 is equal to cosecant squared. That's just by dividing by sine. By sine squared. Divided by sine squared. So you get cosine over sine is tangent, So and then sine squared over sine squared is 1. 1 over sine squared is 1 over secant squared. Both of these are from the same way. We got them the same way. Just divided by sine squared and then divided by cosine squared. But let's use these and try to solve a problem. Given that sine is equal to 1/3 and cosine is less than 0, meaning negative, find the exact values of the remaining 5 trig functions. Okay, so you can do this in two ways. One is using the Pythagorean theorem. Oh, by the way. So here's what it looks like because I got sine to be 1/3. So sine to be 1/3 is that, so sine is positive. That means that I can have positive 1 over hypotenuse, like that. So it can only be in this place, right? Let's see. Yeah, so I'm going to use the Pythagorean theorem to find the value there. So here I have 1 squared plus x squared is equal to 3 squared. Right? This is not the unit circle anymore. Right? So I'm going to find out how long x is. And, I subtract both sides by 1, and then I square root both sides. I get positive and negative 2 radical 2. Now remember, if for sine to be positive, it could be in the second quadrant or the first quadrant. You could have another one over here. But the thing is, it says cosine is negative, so it has to be in the second quadrant. So that's how I know it's in the second quadrant, not the first quadrant. Okay. So I have now, because cosine is negative, I can only take the negative value, not the positive. So x is equal to negative 2 radical 2, and that's from Pythagorean theorem. Now to use the Pythagorean identity, I have cosine squared plus sine squared is equal to 1 squared. So I put that in there. I have cosine squared plus sine is 1/3. So sine squared is 1/9 equals to 1. Subtract both sides. I get cosine squared is equal to 8 over 9. And then I square root both sides. I get cosine to be negative 2 radical 2 over 3. Remember, you can have positive and negative, but then it says cosine is negative. So I take the negative value only. So here you have everything. You have cosine. That means you know this side over that side. So without Pythagorean theorem, you should still be able to see that x is negative 2 radical 2. Okay. So from that, you can do all your other trig functions based on these numbers. Let's talk about trig functions on the graph. So what is a trig function? So it's in this form, like f of theta is equal to sine theta. So if they give you, so the input, they give you an angle and you do sine of that angle and you get your output. So say they give you pi over 4. What is sine of pi over 4? Pi over 4 is 45 degrees, right? So there's pi over 4. And then, so that it's radical 2 over 2 over 1. That's sine, right? Radical 2 over 2 over 1. Now, that's about 0.7. All right, that's your function. You put in an angle, and you get a number, the ratio of the sides. That's the output. If they give you 0 as the input, so that looks like that. So your hypotenuse is still 1, your x is still 1, but now your y is 0. So it's 0 over 1 equals 0. If they give you pi over 2, so you know that the x is 0, hypotenuse is 1, but the y is 1. So it's 1 over 1, which is 1. So that's just an input-output of the function. Now you think about this. Now I can put any angle into this circle, and I will get a value, because it'll give me something over 1. And something over 1 can give me a value. If you get something over 0, that's a problem. But there's nothing over 0 because the hypotenuse is always 1. So the domain of sine is all real numbers. The range is it's greater than -1 and less than 1, right? Because it stays between -1 and 1. Okay, because your opposite, your y, can never be bigger than 1. So your overall value is always going to be less than 1 and greater than -1. The period is 2 pi. Now the period is just when does it return to being the same. So I start here, I go all the way around, and it's the same again at this point, 2 pi. So in our table here, let's write down these things so we know what they are. For sine, again, all real numbers. Range is greater than -1 and less than 1. Period is 2 pi. Okay. Cosine, same idea. I'm not going to explain exactly how it works, but these are the values. These are the characteristics of these graphs that we want to write down. Okay. Tangent is a little bit different because it's opposite over adjacent, which is you have x at the bottom. So the domain can't be when x is 0. Okay, like you see here, pi over 2 is when x is 0. So the domain can't be where pi over 2, and then add k pi. Every time you go another pi, x is 0, right? So down here, you can't have that either. And then you go another pi up here, can't have it. X is 0. So domain is when theta is not equal to pi over 2 plus k pi. All right. And then here's the range is all real numbers. And I'm just going to go through these. Cosecant is hypotenuse over opposite, so y at the bottom. So when is it that you can't have the domain? Is when y is equal to 0. So at 0, or over here at pi. So your domain is, you can't be equal to k pi. K is any number, right? 1 pi, 2 pi, 3 pi. You can't have that. For secant, same thing. You can't have x at the bottom. So it shares the same one as tangent because they both have x at the bottom. All right. And I'm going to give you the rest of the values here. And then we do some examples here. So find the exact values based on the periodic nature of the function. So use the period for cosine to find out what this is equal to. Because the period is 2 pi. That means that every 2 pi, it goes back to the same. So I just subtract a bunch of 2 pi's from these guys. So I want to make it into something over 4. 2 pi is 8 pi over 4. And I want to subtract a bunch of 8 pi's. So that I go back to a small number within the circle. So it's pi over 4. So cosine of 33 pi over 4 is just the same as cosine of pi over 4. Because I take away just a bunch of these periods, right? So cosine of pi over 4 is radical 2 over 2. Same thing here, tangent of 9 pi over 2. What is the period of tangent? It's pi. So I have to take away a bunch of pi's, right? Pi is equal to 2 pi over 2. So I subtract 2 pi over 2, subtract 2 pi over 2, and I get pi over 2 at the end. So tangent of 9 pi over 2 is equal to tangent of pi over 2. So it's undefined because pi over 2, remember pi over 2 is when it's up here and the x is 0. So tangent have a 0 at the bottom, so it's undefined. Now, if they give you something like a degree like this, same thing, use period of pi period is 2 pi, and convert that to degree, because this one is in degree. So 2 pi is 360, and you subtract 360 and you get 60. So sine of 420 is equal to sine of 60, which is radical 3 over 2. And here cotangent of this, again, use the period and convert that to degree. Period is pi, so it's 180. And I subtract a bunch of 180 until I have a small enough degree inside the circle. So 45. Cotangent of 45 is the same as cotangent of 585, which is 1.